Alright, so our problem-solving example says Fahrenheit temperature F and Celsius temperature C are related by a linear function. Water boils at 100 degrees Celsius or 200 degrees Fahrenheit and freezes at 0 degrees Celsius and 32 degrees Fahrenheit. Question A, write an equation expressing F in terms of C. So, few things here in the reading. Notice that this says related by a linear function. Okay? That is a big thing that we know. We're given that information. And then something that we know stemming from that is that linear functions can be expressed in y equals mx plus b slope-intercept form. We know that there's two other forms for linear functions, point-slope form or standard form, but y equals mx plus b is usually the one that we use the most. Now, not every word problem that's a linear function is going to come straight out and tell you that it's a linear function. So other key words to look for is if it says that there's a constant rate. If you see that phrase constant rate, that is telling you that it's a linear function, because linear functions have a constant rate of change. Alright, the other thing is our variables. So when you're problem solving, you can use letters that represent the things that you're looking for, or you can use X and Y, but you always want to write down what it is your variables are representing. So we can use F for Fahrenheit, and C for Celsius, like they gave us right there. Or we can use X and Y, but if we use X and Y, we don't just want to assign them randomly. So the wording of this question, very important. Write an equation expressing F in terms of C. This tells us that C is going to be our independent variable. F is going to be our dependent variable. F is going to depend on C. Now, in this issue of temperature with two different units of measure, equations can be written either way. The independent and dependent can be interchanged. In other problem-solving situations, it's very obvious which variable is going to depend on the other. But this means that if I want to put X and Y here, I would put an X for Celsius, and I would put a Y for Fahrenheit. And so what your variable represents, that is key to problem solving. So that means if I were to graph it, right, my Celsius would be here, and my Fahrenheit would be on my y-axis. So again, thinking independent, dependent. Alright, so we need to write the equation. So I'm looking at a linear equation. Y equals mx plus b. I need to know the slope. Alright, so I don't have any more room to write on this paper, so I'm going to write on my notebook paper here. Slope is equal to y2 minus y1 over x2 minus x1. So in order to know the slope, I need to have two ordered pairs, x and y. Well, I'm given those two ordered pairs actually. 100 degrees Celsius, 200 degrees Fahrenheit. That's an ordered pair. Celsius X, Fahrenheit Y. So I have an ordered pair at 100, 212. Then do you see I have another ordered pair, 0 degrees Celsius, 32 degrees Fahrenheit. So 0 and 32, that's my other ordered pair. X1, Y1, x2, y2. It wasn't written in an ordered pair form, it was written as a sentence, but there's my two variables related to each other. So now I'm going to come plug that in, and I'm going to have 32 minus 212 over 0 minus 100. I'm going to pick up my calculator. 32 minus 212 should give us negative 180. 0 minus 100 should give us negative 100. I'm going to go ahead and divide both of these by negative 10. That'll give me 18 over 10 because I do that in my head. And then if I divide by 2, that'll be 9 over 5. So there's my slope. Now, looking back again, slope-intercept form, I need to know my y-intercept. Well, in this word problem, I actually know my y-intercept. The y-intercept happens whenever x is 0, right? Look at a graph. You're going to cross the y-axis. Wherever you cross the y-axis, isn't x equal to 0? Yes. So I actually already know my y-intercept. So I already know that this equation is going to be y equals 9/5 x plus 32. Or if I wanted to use the variables f and c, it would be Fahrenheit equals 9/5 Celsius plus 32. But you might be thinking, Miss Collier, what if they didn't have that point? Like, what if there wasn't a 0? What if my other point had a 10 or a 20 or some other number? Can you remind us how we're supposed to find the y-intercept? So yes, let's do that. So if I know y equals mx plus b, then I can take my ordered pair here, and I can use this x and this y and my slope that I found, and that can help me determine b. So I'm going to plug in a 212 here. I'm going to plug in a 9 over 5. I'm going to multiply by 100, and then plus b. So I'm going to take my calculator and use it to do 9 divided by 5 times 100, or 900 divided by 5, and I'm going to get 180 plus b. Then I'm going to subtract 180 from both sides, and that's going to tell me b is equal to 32. And then I would take that value for b and plug it in with my slope and get my slope-intercept form. All right, next question. What does the slope mean in this context? All right, so letter B. First, what is the slope? What number is the slope? 9 over 5. So we know we have an equation for slope, but the meaning of slope is change in y over change in x. Remember, that little triangle is delta. It's a Greek letter, and it means change in. Change in y over change in x. Well, again, going back to what my variables are, that's my change in Fahrenheit. Change in Fahrenheit over my change in Celsius. So what does the slope mean in this context? It means the temperature, I'm going to abbreviate, the temperature increases 9 degrees Fahrenheit each time it increases 5 degrees Celsius. So the temperature is going to go up 9 degrees in Fahrenheit every time it goes up 5 degrees in Celsius. That's what my slope is telling me. All right, question letter C. The weather forecaster says the temperature will be 40 degrees Celsius. What is the Fahrenheit temperature? Because we don't really think 40 degrees Celsius. I really don't have an idea. How cold is that? Do I need a jacket? Do I need a swimsuit? If I'm going somewhere and I look at my phone and it says the weather's going to be 40 degrees Celsius, how am I even going to pack? So, we have our equation here. So all we're going to do for this is we're going to plug the 40 degrees in for Celsius. Do you see that if I use the letter C, it's a little bit easier to know where to plug it in than if I have the X. If I have an X, I have to go back and remind myself that X is standing for Celsius. So my Fahrenheit is going to equal 9/5 times 40 plus 32. And you can just type all that into the calculator at one time and arrive at an answer. So go ahead and do that. And what'd you get there? 104 degrees Fahrenheit. Okay? Very warm. You don't need a coat. You need a swimsuit, tank top, flip-flops. No coat required. All right, letter C. No, letter D. That was letter C. Normal body temperature is 98 degrees Fahrenheit. What is normal body temperature in Celsius? So this time they're telling us Fahrenheit and they want us to find Celsius. So now I will need to put 98.6 where Fahrenheit, F or Y is, and then have 9/5 times Celsius plus 32. So then I'm going to subtract 32 from both sides. So give me 66.6 equals 9/5 Celsius. So I'm going to need to multiply by 5 and divide by 9. Multiply by 5 and divide by 9. Or in turn, multiply by the reciprocal. This way the 5's divide out, the 9's divide out, C is by itself. So if you multiply 5 times 66.6 and divide by 9, you should get 37 degrees Celsius. So if you're using a thermometer that measures in Celsius and your temperature comes out to 38 degrees, that means you have a fever. Alright, last question, letter E. Lead boils at 1,620 degrees Celsius. What Fahrenheit temperature is this? So they are giving us Celsius, asking us to find Fahrenheit. So it would be Fahrenheit equals 9/5 times 1,620 plus 32. Again, we've got two variables. The key to the problem solving is to distinguish which one of your two variables do you have, which one of your two variables do you need. So when you carry out that multiplication and addition, you should get 2,948 degrees Fahrenheit. Very, very hot.